The mountain.
Our last lesson for the unit, Simplifying Radicals Part 2. And as promised, I think I promised, this one's significantly shorter than the last one. So our learning goals, we're just going to continue to simplify radicals, but we're going to do trickier ones today. We're going to start with a warm-up from our last lesson. Now there's two ways to do egg, and there's multiple ways to do a lot of these. So let's start off with, maybe some of you are thinking to do this. From our first lesson on simplifying radicals, we know that when we divide radicals, you can just divide the radicands. So if this works, we might be able to do 90 divided by 5, which that actually is a nice number. It's root 18. And 18 breaks up into 9 and 2, which is root of 9 is 3. 3 root 2. So that's one way to do this. It's the only way I'm going to show you, actually. The other way is much more, it takes a lot more steps. So if you're thinking, well, I know that the denominator, I can't have a radical in it, so multiply by root 5 over root 5, that's perfectly okay. You're going to have a root 450 on top all over 5. It will eventually reduce. Another thing you potentially could do actually is you could reduce that root 90 to root 9 over root 9 times root 10, which would be 3 root 10, and then get rid of the root 5 on the denominator. But as a rule of thumb, maybe check the dividing first before you move into those other ones, which they're perfectly legit. It just what took us 3 steps to get to the final answer. If you did it one of those other 2 ways, it would take you probably 5 steps, maybe 6. B, pretty straightforward. We can't divide here because they're not both roots. So we're going to multiply top and bottom by root 6 because it's bad to have a radical in the denominator. That leaves us with 11 root 6 times divided by 6. Can't simplify any further. That's it. C, dividing 6 by 10 is not going to help us, so let's just get rid of the root 10 by multiplying by, so remember from your last lesson, root 10 over root 10. That will leave us with 5 times root 60 all over 4 times 10. Remember, when you multiply identical roots, it just ends up being that number, which is 10. 60 can be broken up into 4 and 15. So again, skipping some steps, but if you need to show all your work, right? So that'd be root 4 times root 15, root of 4 is 2, and 4 times 10 is 40. 10 root 15 over 40. Simplify if you can, which we can. 10 goes into 40 4 times. So we are left with root 15 over 4. And that's as far as we can go. Root 15 can't be broken down any further. So there's our warm-up from the last lesson, bringing back pleasant memories, I'm sure. Now on to the tricksy ones. if I look at A and B, what's different about these two versus the other ones, there's not just a single term in the denominator, there's actually multiple terms. How do we get rid of those? Well, here's the key. You want to multiply by the conjugate. If you're not sure what's meant by conjugate, that just means opposite. And if we go back a lesson, when we multiplied a binomial, and what they were identical A and B terms, but the middle, the sign, one was positive, one was minus, it canceled out the middle terms. So we're going to do the exact same thing here. What we're going to do is we're going to multiply by the conjugate, which is the opposite. So 2 root 6, but instead of minus 5, it's the opposite, plus root 5. All over 2 root 6 plus root 5. And again, we're not changing the value of the question because anything divided by itself is 1. So just to reiterate, when you have these things with 2 radicals in the denominator, you want to multiply by the conjugate, which means the sign in the middle changes. So now it's kind of like distributed property. And if you need to, you can put brackets around these things. So you're going to multiply 3 by both things. 3 times 2 is 6, so that's 6 root 6 plus 3 root 5. Now we're going to do a FOIL on the bottom, so like first, outside, inside, last. So first times first, which would be 4. 2 times 2 is 4. Root 6 times root 6 is just 6. Outside, so 2 root 30. Inside, we should end up with negative 2 root 30. And then last would be minus 5. Once you're there, there's nothing to do in the numerator. There's no breaking up, there's no like terms, so it's just 6 root 6 plus 3 root 5. 4 times 6, 24. And then as promised, these two middle terms cancel out. That's why we did it. And we're left with 24 minus 5. 6 root 6 plus 3 root 5, 24 minus 5, 19. And we have successfully done it. We have got rid of the radicals in the denominator. And you can see why it does that when you multiply by the conjugate. We're going to try the same thing for b. This time we're going to multiply by root 10 minus root 7 over root 10 minus root 7. And if it helps you, you can draw brackets around. And then FOIL. So first times first, root 30, outside minus root 21, inside plus root 50, last minus root 35. All over, same thing. Root first times first is going to be just 10, right? Minus root 70 plus root 70 and then minus 7. And if you look in the numerator, you're looking to simplify if you can, or collect like terms. So let's start with root 30. Root 30 does not break up at all. Root 21 does not break up. Root 50 does, 25 and 2, so that's 5 root 2. 35 does not break up. And you're just left with 10 minus 7, right, because those cancel. 10 minus 7 is 3. And that's it. The last thing I was going to briefly gloss over is simplifying cube roots. So we've only been doing square roots, which the index is 2, meaning something times itself twice. But there's an infinite number of roots. So here we're going to work with cube roots, which cube roots just means something times itself 3 times. So you're looking to break this up with numbers like 8, which is 2 cubed, right? And then 27, which is 3 cubed. And then the next one would be 64, 4 cubed. And then 125. We'll do one more, 216, 6 cubed, and blah, blah, blah. So for A, we have 5 and then the cube root of 32. So 5. And we want to break this up into nice cube roots, right? Not square roots, because the index has a 3 there. So we can break this up into 8 and 4, because the cube root of 8 has a nice number, times the cube root of 4, minus that 2. And then 81 is 27 and 3. Cube root 27 times cube root 3. The cube root of 8 is 2, so this is 2 cube root 4 minus 2. The cube root of 27 is 3, so that's 3 cube root 3. 5 times 2 is 10, so 10 cube root 4s. 2 times 3 is 6, minus 6 cube root 3s. And we cannot combine those because those do not have the same radicand. They're not quote-unquote like terms. The next one, cube root 25 or 125 is actually a nice number right off the bat. So that's just 5. So 4 times 5 and 20. 128, hopefully you're thinking, can be broken up into 64 and 2. So this would be 3 and then cube root 64, cube root 2. Cube root 64 is 4. So this is 4 cube root 2. 3 times 4 is 12. 20 plus 12 cube root 2s. And again, do not do 20 plus 2 is 32. This is not like terms. So that's as many examples I'm going to do. Like I said, just kind of glossing over it, exposing you to cube roots. You will see cube roots again in grade 12U functions. So that's it for video lessons for this first unit. Your C work basically is just to prepare for your test, which could mean finishing the rest of that package. There's also an optional review. I've taken a picture of out of the textbook that you could try some of those questions if you really wanted to. And then don't forget, you are starting your test between 12:15 and 1:15 on Wednesday. And from whenever you start, you will have 2 hours and 15 minutes. You are doing just a quick review. You go to assessments, quizzes, and then click on the Unit 1 test. It won't be there for you to see though until 12:15. So if you don't see it right now, it's because it's not actually active yet. You do your test solutions all on blank paper in order. And then you are going to answer on both the D2L quiz, but this is your final answer. And then you are going to submit your solutions. I would very much prefer if you were able to learn or practice between now and your test on how do you take a picture from your phone of all of your pages and save it as one file. Preferably a PDF because it compresses it and it's small and you should have no issues with uploading it to D2L, which means you're going to have Brightspace on your phone, or you should have Brightspace on your phone. Your test solutions should come in within at absolute maximum within 15 minutes of your test submission. If you weren't aware, as the teacher, I can see the exact moment and second that you started the test, when you saved each question, your IP address. I can see when you finished the test. So if you finish the test after an hour, but I don't get your test solutions until 2 hours later, that's not going to fly. So just so you know as well, everyone has a unique version of the test, meaning everyone is writing a different version of the test. So you do your own work on your blank paper. If there's ever any issues with interpretations of questions, just make a note on your test solutions, submit them, and if you get them submitted as one file, whether it's a Word document or a PDF, that's fine. You'll get 1 bonus mark for every test that you're able to do that. If you can't figure it out, you can watch the how-to videos. If you still can't figure it out after watching the how-to videos in the how to virtual section, then obviously just submit individual images of your test solutions. If you have any questions about the test or anything coming up, make sure you let me know and ask me any math questions you have. Good luck in preparing for your test, and once you're done, you'll be one of 7, maybe 8 units out of the way.